Discovery Lab that you've attended, if you've attended some in the past, some of our virtual ones, or if you've even attended some of our in-person Discovery Labs. We would love to hear where you're from and if you've joined us before. And again, you guys are more than welcome to throw that in the chat. So we have a first timer. Welcome. Good way to start the new year. So since it is 6 o'clock on the dot, we will go ahead and get started as some more folks come trickling on in tonight. But I do want to welcome you guys to our Discovery Lab for this month on hurricanes. So I'm Tara Rudo. We're joined by Sarah Nuss as well. So we work over at the Chesapeake Bay National Estuarine Research Reserve over at the Virginia Institute of Marine Science. And this is a program that we host every month on a various marine science topic. We also have Trinity joining us. She's an eco ambassador, so she'll be leading our trivia for this evening. And we have our guest speaker as well. And you'll definitely hear more from her a little later. But if you guys are interested in attending some future Discovery Labs, we have our topics and our speakers set up for the rest of the spring. So we have in February, Pole to Pole. March will be the slimy life of eels. April are going to be shells. And then May is nitrogen, carbon, and marshes. Oh my. Now, we've had a lot of people ask, are these going to be in-person events? Currently, we have been given the go-ahead to have our February Discovery Lab be in person, which is great. That is subject to change with everything going on. So definitely follow us on our social media platforms, on our Facebook and Instagram especially. We will be posting updates to all of those Discovery Labs if there's any changes, if they're switched back to virtual. Any questions you guys have too, you can message us through those platforms. And just give us a follow as well. You can stay up to date on what CBNERR-VA's been working on, some of our research and future programs. And tonight, we will start our presentation with our guest speaker, Dr. Dalia Kirschbaum. And did I pronounce that right? Kirschbaum? Yep. And we'll be doing a live Q&A session right after, so you guys will have a few moments. And during her presentation, if you guys do have some questions, we ask that you throw it in the Q&A section of the chat. It's right next to the chat option. And then Sarah and I will feed those questions to her, and you guys can have a short Q&A. We'll be doing a hurricane house hunters demonstration. It's something you guys can even do at home. And then we're rounding it out with a Kahoot trivia game all about hurricanes led by Tiffany. And with that, I do want to introduce our speaker from this evening. So usually we have a speaker from VIMS, but we unfortunately don't have a hurricane expert here at VIMS. So we reached out, and Dr. Dalia Kirschbaum was very generous in giving up some of her time tonight to speak with you all. She is the chief of Hydrological Science Laboratory at the NASA Goddard Space Flight Center in Greenbelt, Maryland. She's attended university in Princeton and also in Columbia University, and that's where she gained her PhD. And she's done a lot of work with NASA, especially working as the disaster response coordinator for the agency. And she's going to be able to tell you guys more about how she got into this position and her work that she does with NASA and how it relates to tonight's topic. And again, if you guys have any questions during the Q&A, please leave it in the Q&A section. And we'll go ahead and get started. I will turn it over. Let me stop sharing my screen. And the floor is yours.
Wonderful. Well, let's do a quick tech check. Everything look okay? Perfect. Well, it is such a pleasure to be with you. Thank you for joining tonight to learn. Hopefully I can share some interesting, helpful information about hurricanes, what NASA does to study them, and maybe some things that you can learn and share with others. As Tara mentioned, I'm chief of the Hydrological Sciences Lab in Greenbelt, Maryland at Goddard Space Flight Center. It's one of the largest, it is the largest science center that NASA has. And Earth Science, we have over 1,400 people that are looking at different aspects of our planet, developing new missions, new science models, and data products. So I've been here at NASA Goddard for about 12 years and have moved through different research activities. But I wanted to just give you a little bit about where I came from, about me. So when I grew up in Minnesota, and this is me at Kennedy Space Center when I was about 8 years old. I really liked math as a kid, but I wasn't quite sure how to apply it. And so through talking with teachers and professors and really getting inspired by science, specifically by disasters, I pursued a graduate degree, a PhD in remote sensing and hazards with a focus in landslides, which is what my area of research is. And I went on from there to get a postdoc and a research position as a civil servant at NASA. This is a view of me in a clean room, one of the largest clean rooms in the world, with a fully assembled spacecraft called the Global Precipitation Measurement Mission. It's about the size of a small school bus that was launched in 2014. And so, in some of the work that I do, this is a pretty unique case, but I've been able to engage not only in building missions and working with stakeholders, but how we apply that data. And a little bit more, I do a lot of outreach and communicating of science, which is so important, and highlighting how we take this type of information from satellites, from the ground, and from models, and how we can really use it to better understand our world. So on the top, this was actually a billboard that was going to go up in Minnesota, in my hometown. Unfortunately, for a whole lot of reasons, it didn't, but we got the priceless pictures. And we also led launch campaigns for the GPM satellite, as well as live shots or communication activities with different media outlets. And so this is just some of the pictures of what I do. What I really wanted to share with you today is about hurricanes. And so, I wanted to start with a story. In August of this past year, 2021, Hurricane Ida impacted the Gulf Coast, right? It impacted Louisiana, specifically New Orleans. These are images from New Orleans along the coast, and the impacts that we experience from hurricanes, from those that live in coastal communities, are very personal. And so the challenge is, how can we take this information? How can we take this global data that we have at NASA and help us to understand the impacts in our local communities? And so I wanted to start with that and then talk about what we're learning or what we've observed and how we've contributed to understanding hurricanes and their impacts. So one specific example, this is a view of the Global Precipitation Measurement Mission, or GPM. Hurricane Ida was a deadly and destructive Atlantic hurricane. It was actually the fifth deadliest and caused $75 billion. It was the fifth costliest tropical cyclone on record. And so through this ability, let me replay this, through our ability at NASA, we can actually look layer by layer through these storms to help understand the distribution of precipitation. And that's what you're seeing here. Snow at the top of the hurricane, and you see green to red indicating light to heavy rainfall. And by being able to get a cross-section or a view of this storm, we're able to really truly look at how these storms rapidly intensify and how their extreme precipitation may inundate land. And so that's one of the big challenges and research questions in the community is how do these storms move and rapidly intensify, ultimately impacting communities? So in addition to looking three-dimensionally, we can also use satellites, not just one, but a constellation of satellites around the globe, to understand the accumulation of rainfall, how this storm may impact different communities as it moves overhead. And then we start to look at what the impacts might be. So what you see here is a view of Lake Pontchartrain and the New Orleans area from before the event. And then you can see the impacts after the event. And so the white areas are clouds. This is a view from our Landsat satellite. And so what you can observe here is some of the inundated areas, the affected estuaries or the delta coming from the Mississippi, which is, goodness gracious, which is wandering through New Orleans. And you can start to see some of the suspended sediment or even the pollutants that are impacting Lake Pontchartrain as the storm made landfall and started to affect and cause flooding. Other things that we can do with this storm, we can start to understand the distribution of how we take different data and input it into a model. So what you're seeing here is actually a soil moisture model as the storm made landfall over the New Orleans area and moved more inland. And so by working on by looking at how we observe the changes in soil moisture from really dry to really wet. That's an important information. Let me pause this here. This is important information for groups like FEMA or for local emergency responders to help understand where it might be wet before a hurricane makes landfall, but then also how to effectively respond, or what might be the flooding impacts after the storm moves over the coast and comes further inland. And so with models, we can bring together precipitation, like you just saw, with soil moisture from satellites, and bring that into a modeling framework to provide near real-time or dynamic information on modeling, on the impacts of these storms. But as I mentioned, the impacts of storms are also quite personal. And so this is a view of New Orleans, the power outage, the power from New Orleans. You can see this is the downtown. And this is a view from the NASA NOAA satellite called SUMI-NPP. Well, what we know is that we can observe these nighttime lights, we call them, from the storms, and we can also observe after the storms have made landfall, what the impacts of power outages could be. Now I'll just flip back and forth. This is the view from before the storm, and this is the view several days after Hurricane Ida impacted New Orleans. And this is just a couple months ago. I happened to be there in December and looked at how they are building resilience and how they've rebounded from this event. But the long-term power outages that existed in some communities were tremendous. And so emergency responders use this type of information from satellites to really understand where to install generators, what communities might be most severely impacted by these events. And so I just wanted to give you a view of just one specific storm to talk about how all the different ways in which we can really understand and advance our awareness of landslides from a research perspective, but also how we can use this data to really impact people and help them. Now, NASA is a research agency. We're not an operational center, but we help to enable activities. And I'll give you some examples of how. But first, let's talk about what a hurricane is, right? So this is a view, a cross-section of a hurricane. You need several different ingredients for hurricane to form. You need surface water or ocean temperatures to be higher than 26 degrees Celsius. You need some warm water to fuel these heat engines of storms. You need some existing storms to start this process. And then you need to have some winds that begin to have these storms spinning. And so as the temperature of the water increases, the pressure, the air moves up into the hurricane, it then moves out. So it creates a high pressure zone at the top. It then the air moves out. And as that air rises, it transforms its heat into precipitation. And so that's why you get these extreme precipitation bands in the storm. They're called rain bands. And so this movement of air into the eye of the storm and then vertically up through the atmospheric column, out at the top, this is kind of the cycle that we call the hurricane heat engine. And the air is affected by the warm surface water in this deep pool of water that acts as that engine of the storm, which is why the storms tend to dissipate once they make landfall, because it doesn't have this warm pool of water. But as temperatures are rising, and we'll talk about that, these dynamics are changing both in the ocean as well as on land. So what I wanted to do is talk a little bit about how NASA is supporting the life cycles of disasters, not just in the immediate response, but how we are working with recovery, mitigation, and even preparedness and what we call a disaster life cycle. So first, one of the things that NASA does is develops and implements missions, which can look both optically. It can look at the tops of these hurricanes. It can look three-dimensionally through them to look at precipitation. It can look at the surface winds through satellites such as Cygnus. And these are very important tools to support operational forecasting, right? This data is being brought into operational models by the National Hurricane Center at NOAA and other prediction centers around the world. And then during response, as you've already seen, we have information that's valuable for first responders, decision makers at both community levels up to national levels. And so that type of information is enabling additional support or decision-making needs by these different communities. We have a disasters program at NASA that helps facilitate some of that information. And we work across earth science and flight to better support these efforts. We work with industry and other governments, supporting relief organizations on the ground, particularly in areas outside of the US. NASA has a global focus. And then we also bring this information to bear to understand how models can predict this, how we can improve our understanding of storm dynamics, how they move, how they evolve. And ultimately, the goal is to transfer that knowledge into fundamental research and understanding to then improve forecasting. So you can see how this is a cycle in terms of our knowledge, contributing, advancing our understanding, but then really transferring that into knowledge that can empower decision making. So just a little bit about before hurricanes. What do we do? Well, we design, build, and launch all of NOAA's weather satellites. I don't know, that's a little fact that most people don't know, but most of the NOAA weather satellites you see in space are developed by NASA in partnership and launched. And then NOAA is the operational partner that manages and monitors, uses them. We also support research efforts through funding through NASA to researchers around the United States and in collaboration with partners around the world to really look at how these storms develop, how they intensify. And then we bring this data into satellite data into models to support research and improve our understanding of forecasting that can enable and improve the operational forecast that you all receive when a storm is making landfall. So just two examples. One is development of sensors. You can see an example of one of the JPSS, Joint Polar Satellite Systems that NOAA has developed, but in partnership with NASA. And on the right, you can see an example of a 7-day forecast from one of our modeling centers at NASA that highlights the big picture view of some of these disturbances. And we look at not only the rainfall, we can look at the winds, we look at the minimum pressure or sea level pressure to really understand the bigger picture globally of these events and their movement. Now, during the events, as I've mentioned, NASA supports satellite, different supplements information, and uses that data to support understanding and awareness, as well as enabling prediction and forecasting. We also provide information used by decision makers, such as soil moisture, to look at this kind of pre-event impact or post-event analysis. And then we work with NOAA to ultimately provide support in aircraft. So NOAA's Hurricane Hunter aircraft, we also have a NASA aircraft that can support those efforts from the air, or support those efforts from the air. And these are just two examples. So on the left is the GPM data in NOAA's operational system called AWIPS. And so the idea is that we are not only taking the data and giving it to people, but we're working on the formats to make this data more actionable, right? We can use it to actually make decisions, and they can use it directly. And that's a huge part of building capacity of other agencies to use the satellite data. Another example, this is just an example from my research, is how we take precipitation information and we can put it into a landslide model, which we now have running globally in near real time. And this type of information is being used by groups like the Pacific Disaster Center, by the Department of Defense, and others to really understand the awareness of cascading impacts from hazards like landslides. And then following hurricanes, we work with recovery organizations, not only our federal partners, but also non-governmental organizations and others to monitor infrastructure failures, such as power outages, look at contaminated water supplies, and even other cascading hazards that I mentioned. And so two examples, this is just from Hurricane Maria, and it shows how satellite data was used to track the recovery of power after Hurricane Maria made landfall. And this was a devastating example of how long it took to regain power. And this type of information was used by the National Guard to install generators in some of these highly vulnerable communities. But we can also look at the flooding and impact of sediment to rivers, local rivers, as well as to ocean basins that can affect fisheries. This is a big example. Hurricane Florence impacted the Carolinas. It had a tremendous impact on fisheries with sediment clouding the water and decreasing the amount of essentially food for the living organisms there. And so this type of information, this is from Landsat, allows us to really look at the evolution, not just of our surface, but also in our atmosphere and even in our subsurface. So where does this leave us? Well, this is just an example of the 2020 hurricane season. It was the most active hurricane season we've had. And this is just an example of why we need to look at things as an integrated system. So what you see here is the GPM, or the precipitation data from NASA, which I mentioned before. You can see sea surface temperatures in the reds to blue color, and then you can start to see the movement or the tracks of these storms. And so by being able to really look at the different components of what is driving and moving hurricanes, we can get a better understanding of how they might change in the future. Now, one of the most important components is how our climate is changing. We know our climate is changing. We know that humans are the cause through release of carbon dioxide, through things like burning fossil fuels in cars, in industry. And so now our job is to monitor those changes and ultimately use that data to project out into the future. We do this in concert with many other organizations around the world. You may have seen last week the temperature announcement that this past year was one of the top 7 hottest years on record, and the hottest years on record were the past 7 years. And so we know that these increases in temperature are really having a significant impact on our environment and a specific impact on hurricanes. And so in a warming world, we know that warm air holds more moisture for rainfall. So we see things like more intense precipitation, as well as, so wet areas are getting wetter, dry areas are getting drier. We also know that this warm pool of water I described before, they can increase hurricane power. You know, as this storm made landfall, or as the storm moved through the Gulf, Hurricane Ida, it rapidly intensified from a category 1 to a category 4 in just less than 24 hours. Maximum sustained wind speeds 150 miles per hour. Now, this is, this is growing in frequency. And we also know that because of the warmer water, these storms are also slowing down, similar to what we saw with Hurricane Harvey. Harvey just sat on the Texas coast for a long time and dumped 40 inches of rain in parts of Texas. Now, this is anomalous activity, but we will see it more frequently in a warmer world. And we've already started to see those impacts with an active 2021 hurricane season as well, and beyond. And then the other thing for people, especially living in coastal regions, is rising seas will increase storm surge. So I'm sure that you've all experienced this in some way if you're living on the coast, and how these storms make landfall and how the increased tide or the tide may impact the storm surge level is something that everyone in coastal regions should be increasingly more aware of, because as we know, as sea level rises, there is more opportunity for storm surge, and which can cause issues with saltwater intrusion going into reservoirs, as well as impacting the ecology of the region. So what are we doing about it, right? I want to leave you with a message of hope. Well, NASA's Earth Science Fleet has a tremendous number of satellites, both in operation as well as beyond their mission life and in formulation. And so what you see here is in boxes are the satellites that are directly contributing to supporting hurricane research, advancing prediction, and really enabling models in that space. And so we even have some satellites in development that will be launching soon. We have also Landsat 9 that just launched, we're very excited about, as well as other information on the International Space Station, and in collaboration with international partners. Together, we are working to better understand and grow research on this challenging topic so that we might improve forecasting and ultimately save lives. So then the last question is, what can you do, right? I mean, you're hearing this information. We know what causes hurricanes to form. We're working on trying to figure out more about what makes them intensify, specifically rapidly intensify. Can we do a good job forecasting that? But as citizens, what can you do to be more aware? So my response to that is to learn and to share. So what can you do? Well, the first is to be informed. We have so many different websites that point to new and current information on how our climate is changing, the different hurricanes that are out there and types of information, and we can share this information afterwards. And be involved. There's activities such as the GLOBE program or citizen science, even my landslide research. We have a citizen science project called Landslide Reporter. And you can be involved in these efforts to report precipitation information and other activities. And then most importantly, be inspired to share that with others. So I'll leave you with this. This is a visualization of a model that shows the hurricane season from 2017 in terms of aerosols. You see smoke coming off of Africa, you see sea salts in blue, and then you see fires that are originating on the west coast of the US. And what this shows is everything is linked. And so what our role is at NASA and working with our community is to integrate and link these processes so we can better understand and advance our awareness of hurricanes and improve lives and save lives and property. So thank you so much. And I'm very happy to take questions.
Awesome. I loved all of your models and graphics. That last one especially was very interesting. And I know I loved how you were touching on, the coasts are impacted by these hurricanes. As someone, I've lived in central North Carolina and then on the coast, and I've even experienced hurricanes and the impacts they have further inland. So it can definitely affect a lot of people. But we do have a question in the Q&A. So this person was asking where they can get real-time detailed information on rainfall amounts associated with major storms. They live, their community is built around a lake that's formed by an earth dam. And they would like to have more detailed rainfall data to determine how much they need to draw down on the water before a storm impacts their community. So they're looking for some ways to get that information.
That's a great question. One of the challenges with some of the satellite data is that it is a little bit more coarse in resolution. So the data that I was showing from GPM is actually 10 kilometers by 10 kilometers, like that, a little over 6 miles by 6 mile grid. So I have a feeling that just one of those pixels would fit in your community. And so that type of information may not be as relevant at the local scale. But what I will say is that NOAA has a lot of different, so the National Oceanographic and Atmospheric Administration has quite a few rain gauges that you can take a look at and compare, as well as radar products. And another activity that I would actually strongly recommend looking at is the community COCO-RA. So it's the community coordinated, you're shaking your head. I can't remember the acronym, but we could put it in the chat. And that is actually a community-based system for people that have rain gauges near their houses to report daily their rain information. And so that could also be a really interesting, thank you so much, Sarah. That could be a really interesting resource for you, and even to get involved if you want to be more aware of what's happening in your area. They have trainings, they have a national network, and so locally that could be an interesting way to get more involved and learn more about the rainfall products relevant to your area.
Perfect. Great. I like this question. It's kind of funny. What would you do if all of your satellites broke?
That would be very, very sad on multiple levels. So, I guess I'll answer that question in a different way, is that, the US government is investing billions and billions of dollars on satellites, right? We would not be able to survive with satellites, right? Our phones rely on them, right? For GPS, for telecommunication services, our power grid relies on them. So satellites are a fundamental part of us living on this planet at this point. And we actually have different groups that help to forecast when satellites might have problems. So for example, space weather, when the sun kind of goes through different phases, we actually have monitoring systems operationally with NOAA to say, to understand what the impact of the sun might be on satellites and preemptively protect them, if we can, and the astronauts in space against these space weather events. We have collision avoidance teams at NASA for the debris, right, that we've seen, the space junk, so that satellites can actually maneuver around the space junk, since even small parts of them can really impact satellites. Yeah. So they're a fundamental part of all of us living on this planet at this point. And so we do everything in our power, working internationally to protect that asset.
Perfect. Wyatt and Dylan are wondering how many hurricanes occurred in 2021. I know you talked a little bit about the 2020 season.
Yes.
I'm not sure if you know on top of your head.
I'm going to Google it right now. But what I can say is that, the hurricane season begins in June and ends in November 30th. So it's pretty it's pretty significant in terms of a span. I'll say that in terms of total storms, we had 21 storms, 7 hurricanes, and 4 major hurricanes. And in total, we had about 161 fatalities, and actually 150 of those were actually from Hurricane Ida, and I think 95 of those were in the US. So we have seen fatalities from these storms. Now, how that compares to, I'm just going through the numbers, how that compares to 2020, which was really unprecedented and set a record high. We had 30 storms, 14 hurricanes, and 7 major hurricanes. And the total damage was over $51 billion in damage. So in terms of the storm damage, Hurricane Ida was actually more significant in terms of damage than the whole 2020 season. But obviously it caused significant number of fatalities, over 400 fatalities for the Atlantic basin. And we continue to kind of be mindful of how these storms impact different coastal regions and have different impacts, especially if they come sequentially, like we saw in 2020, Definitely. The storms being impacted one after the other, which can really hurt. It really hinders communities' ability to recover.
And then someone was asking, so we've talked, of course, about what the US is doing and what NASA does. Are there any kind of efforts or similar studies being done on the international level? Other countries are doing it. Do you collaborate with those countries, things like that?
Absolutely.
And I think related to that is someone else's question, is there an upper limit to the number of satellites that can orbit Earth? So since we know what we're doing and what people in other countries are doing, how do we know when we've reached that maximum?
It both excellent questions. So let me start with the first one, and then I'll go to the second. So at NASA, we collaborate all the time with international agencies. In fact, most of our satellites we wouldn't be able to do without international cooperation. For GPM, for example, the mission that I've been working with, we co-led that mission with the Japanese. And so we actually built the instruments here, one of the instruments here in the United States in combination with Ball Aerospace. And then the Japanese built the other satellite, the other instrument. We assembled it all at NASA Goddard, where you saw my picture. And then we flew it to Japan to launch. So that, and the same with the James Webb Space Telescope, which was just launched and is working beautifully. We're so excited. The largest telescope ever and in space. And so these types of international collaborations are fundamental to really building awareness of the research. So, working to understand the big science questions, not just as a nation, but as an entire world in Earth science. It's a global effort as well. But in addition, is collaborating on satellites. Now, the second question is about, is there a maximum capacity? And that's a great question. I have no idea. But what I will say is that space is really big and that satellites don't just orbit at one altitude, right? So you have some satellites that are what's called a low Earth orbit. And so that's basically like 250 miles above the surface, like the distance from DC to New York, right? So we have satellites in that range, the International Space Station, for example. And so satellites are designed to be in different orbits so that their instruments can work in different ways. We have some that are kind of in the middle orbit, like 800, kilometers up, and I'm mixing units, sorry. And then there's some that are, really far out in the geostationary orbit, 22,000, kilometers away. I'm pretty sure. So I guess the point is that because of the different altitudes for the spacecraft, that it offers a lot of space. That said, with so many commercial companies providing a lot of different CubeSats to give us this frequent revisit time of our Earth, that is really challenging our global ability to make sure that we keep all these satellites safe, going to the question before. And so that is continuing to be a bigger and bigger challenge, but also an opportunity to leverage that data to better understand our Earth. So it's a dynamic, ever evolving process of understanding satellites.
And I used to think that they all were on the same altitude and orbit until I learned about, the Hubble telescope was launched much further away than where the shuttle used to go. So it took some time for me to learn, but we just have time for maybe one more question. There are a lot of questions in here.
Can we take one from the chat?
Yes.
Just because we haven't taken any of those. I think there are 2 questions that related to drones. So maybe that would be a good one to focus on. if you gather any important weather data using drone technology, such as the Global Hawk, and how can drone technology allow you to gather that information that satellites cannot?
Sure. So the Global Hawk is actually an airborne asset, so it's not a satellite. But that is an unpersoned, vehicle. So we are able to fly over hurricanes to understand different components of what they are. And so there's a lot of advantages to that. There's several different types of unmanned aerial vehicles, or what's called UAVs, that allow us to fly different instruments in different locations, right? So you have a pilot in one area, but it is unmanned in space, and so in the air. And so that is a really valuable asset. There's one of the A's in NASA is aeronautics. And so there's a very strong aeronautics program. And then the other thing we do to understand weather is we actually use balloons, right? So we use balloons, and we have balloon campaigns to really look at the different layers of our atmosphere. Before launches, we send up balloons to look at the different the weather conditions, in terms of the vertical profile, to really ensure that our launches are safe. And so there's a lot of value for that type of technology. And we continue to innovate and work with the commercial sector and private sector to figure out how we can better understand, the Earth, not only from space, but from the air and the ground as well.
Perfect. And I know we have a few more questions. I was going to ask if you're comfortable putting in an email address or a way that they could maybe reach out to you if they have any further questions or interest in any of the work that you do, if you wanted to put that in the chat or anything. But we do want to thank you so much for joining us this evening. I know I've learned a lot more about hurricanes and modeling and what you guys do at NASA and how that's helping shape a better future for mitigation purposes when it comes to these storms. And thank you guys for asking those questions.
Absolutely. Thank you so much for the questions. And if there's any students out there, I always like to mention that if you are inspired by any of this, take your math courses, take your science courses. It may not be most exciting. The math might not be super exciting, but it gets really cool when you get to apply it to these types of big issues. So please stick with math and science. Be educated, because it makes such a big difference when you get to this, to the level where you can start to make an impact. So if I could leave with that, that'd be great. And I'm going to put the mission link in the chat, the GPM mission, because if you hit contact us, it comes to me anyway. And then you can get several different researchers that will be able to respond to questions. So thank you so much for having me.
Of course. So again, she'll put that in the chat for you guys. You are more than welcome to stay on if you would like, but we're going to move on to our Hurricane Hunters demonstration. So I'm going to flip over my screen again to our PowerPoint here. There we go. Awesome. So I'm going to put my computer up a little here for you guys. So for this demonstration, we're titling it Hurricane House Hunters. She talked a lot during her talk about how communities are impacted by these massive storms. Even, you can become prepared for these storms when they do occur, but there are still ways to become more prepared, especially as a homeowner. And so this is an activity that you guys can definitely do at home. We've seen it done in classrooms too. So here I've constructed 3 different houses out of arts and crafts materials that I had here in the lab. I know they are not the most aesthetically pleasing looking homes. I tried my best to do 3 different types of homes. So I have them labeled A, B, and C. And so house A here is meant to kind of look like a beach home. So if you guys have ever been to the beach or on the coast, you see those houses and they're on these large stilts or pilings. And so you'll see those a lot of the times in areas that are going to be closer to water. You will also have more like a ranch style home. So these might be more found in suburban areas and neighborhoods, maybe 1-level homes, not on those stilts, like I said before, but usually made of maybe a brick material, sometimes concrete, sometimes those vinyl sidings. So these are a really common home that you see, not just on the coast, but further inland. And then finally, we have kind of like a futuristic looking home. So these are round houses. These are becoming more popular. So as you can see, they get their name because of their shape. They are a round home and they have kind of a lid as a roof. So when we look back at these 3 homes that I've designed and what they're based off of, in the chat, I want you guys to put A, B, or C. Which house do you think would survive the best or do the best against a hurricane? So that can be the storm surge and the flooding. It can be the high winds. Go ahead and put in the chat which house you think would survive that hurricane. And we're getting a good mix, actually. Seeing a lot of A's and C's, a few B's. Okay. Awesome. So I like that everyone's kind of has what they think would be the house that would survive. And so to do this demonstration, I'm going to exit out of my PowerPoint briefly for you guys. And so we are going to demonstrate each house and see how it does against some hurricane force winds. So first up, we have house A. So again, this is the beachfront home that's on the pilings. As you can see, I made it red in color, put a little fish to represent the beach. These houses might be made out of, especially the older ones, they might be made out of wood. Some are made out of that vinyl siding that you see on a lot of modern homes today. So I have my home here and we have a hurricane coming. So to use hurricane force winds, they use categories. So you've heard of category 1, 2, 3, 4, and 5 hurricanes. So category 1 are sustained winds of 74 miles per hour up to 95. And then a category 5 hurricane is anything higher than 155 mile per hour winds. So these are very, very powerful winds that we're talking about, even a category 1. Those can definitely knock out power and can cause damage to homes. So we're going to see how house A stands up against our hurricane, which today is going to be a hairdryer. So if you guys are doing this at home, you guys can use maybe a piece of paper and wave it back and forth as wind. You can use a hairdryer. We saw some demos of people outside using a leaf blower. So if you want to have that be your category 5, I would say this would probably be a category 1 or 2 wind level. And so we're going to see how house A does against our storm. So I'm going to go ahead and start it up. It might be a little loud, so we'll see how it goes. Okay. So in the chat, did you guys notice anything while the winds were blowing that happened to the house? Or if you noticed absolutely nothing, the house is perfectly fine. So again, in the chat, if you want to put, if you noticed anything that happened to house A. So the heat was off. So some people are saying the roof flapped and the siding was flapping. So yeah, as you guys can see here, some of the flaps here actually were coming loose from the glue and the tape that I used. So those high winds, if it was a stronger storm even, can completely rip off these almost like shingle-like siding. They can be found on the roof as well. So especially if these are made out of things like older pieces of wood, these can definitely easily fly apart and cause a lot of damage to the house. Because even though it's protected by the stilts and that storm surge that comes in and those rising waters, of course, maybe your car might not be so lucky, but the overall structure of your house, it's not going to, collapse and fall over on its side. You just might have things like these loose sidings or a part of your roof might come off. So that can definitely be a problem. So now that we've tested house A, we are going to test house B. So again, house B is meant to, let me get this backed up a little so you guys can see. So a ranch style house, I know the roof kind of collapsed a little. But again, this is kind of a single level home, might have a fence in the front yard, might be made out of bricks, concrete even. The roof is going to be sometimes just flat like this or a little slanted, so not as slanted as our beach home there. So we're going to test and see how our ranch style home does against our hurricane forced winds. Okay, so we'll see as I hold down the lawn. Okay, guys. So that one was pretty obvious. You guys noticed that the roof pretty much came completely off. It did hold on this hinge here, which is maybe a good thing. But a lot of times when you guys see pictures of damage to these homes, you see a lot of the damage to roofs. And the roof is a really vital part of the home. Of course, it prevents anything from getting inside, especially excessive rain. But because of this roof being so flat, it actually kind of acts like a sail sometimes if wind is caught underneath it. And so a lot of places that build these hurricane proofing homes, what they do is they tell people to have a roof that's either made out of metal, because basically the metal shingles latch into each other. So it's a stronger roof besides using maybe a vinyl or those normal shingles that you see on the rooftop. And they also say if you angle it at around 30 degrees, that is the perfect way for your roof to be protected from those high winds. So you might not see a lot of damage to the front or the sides of the house. Maybe it was made out of concrete, which is a really good substance to use. Will definitely keep that keep that structure nice and strong against those winds. You might lose, your nice white picket fence. If you have windows, if you don't have storm shutters on them, that glass can definitely break. So using storm shutters, if you're in those areas, some people are even replacing their windows with almost like a fiberglass material. So it's a lot stronger against those winds. But again, since it's not on those stilts, flooding can definitely be a problem for this type of house, since it is a single story. And say you do live near somewhere like a lake where that still might flood during these major events, that flooding might be more of a problem than those winds at times. So house number 2 or house B didn't do too well, but I would say it still survived our hurricane. And then we have one more house to test here. And that is our Roundhouse. I don't know why I made it all gray. I guess pretend it's metal. But as you can see, the house is completely round. It has kind of a lid-shaped roof on it. And so we're going to see how this house does against our hurricane. So hold it down. We'll test our last one here. Okay, so house number 3 didn't budge very well. So this is a pretty strong house, and for a few different reasons. Because of the round shape, it's very aerodynamic. So when wind hits the house, it goes around and behind. And so it is more aerodynamic in that fashion. So there's no weak points in the structure. Also, the roof is slanted at the right degree, so it's not going to fly off like house number 2 did. And then inside of these homes, a lot of the times you find the structure. If you've ever been in any kind of home, you see there's a lot of indoor walls, your kitchen's cut off from your bathroom, whereas in a lot of the roundhouses, it's an open floor plan. And they have these almost like spider-like beams. And the best way I can demonstrate it is that if we were to take an X-ray right through the roof, you would see these beams coming out kind of like in a radius formation. And this helps to strengthen the integrity of the building. And so what we're seeing a lot is a lot of these coastal homes are switching over to this round design. There are a lot of companies that specialize in designing these homes specifically for areas that are prone to hurricanes, because they see, you might have a whole neighborhood wiped out, but the roundhouse survives for various reasons. So we're seeing the future is definitely leaning more towards this type of architecture. It might not be as traditional as we like, but it's definitely, it definitely bears the best when it comes to those high winds. So really proud of House C here. And hopefully next time you guys go to the beach, if you can check out some of the homes and maybe you guys can see one of these houses for yourself. And then this is, of course, like an activity you guys can do at home and test who of your siblings can build the best hurricane-proof home using supplies around your house. And like I said, with adult supervision, maybe you can even use a leaf blower or something of that nature. So definitely a fun activity. I actually enjoyed building these houses, even though I am not the best at arts and crafts, but definitely something you guys can do in the future. And so with that, I will be turning it over to Trinity. Are you able to share your screen? Okay.
Let me try it. It says host disabled.
Okay, I can share it. That's fine.
Okay.
And so guys, we are going to be moving on to our final segment of this evening, which is trivia. And I have to log out of my PowerPoint first. Okay, let me pull up trivia.
Canada, you got fans in the
I
attendance?
know, I see. Really excited you guys could be with us today.
Okay, start.
Oh, yeah, we got a Steelers fan. My favorite.
Okay, I got it pulled up now. And so again, this is Trinity. So she will be hosting trivia for this evening. If you guys are not familiar with Kahoot, I'll explain real quick before I turn it over. So this is a trivia game that we can play online. So if you use a smartphone or another window in your laptop, you can go to www.kahoot.it and it'll ask you to enter this game pin here. So it's that 5265208. You'll enter your name, your family name, and it'll pop up on our screen here. And Trinity will lead us through some questions all about hurricanes and we'll test your knowledge, and you'll get some extra points if you answer correctly and you answer the quickest. So it's good not to just get it right, but to also answer as quickly as possible. So we'll give it a couple minutes to let some people come in.
And if you didn't see in the chat, whoever wins at the end, send Sarah your email so that we can send you a fun prize in the mail. So
Yes.
There are lots of incentives to answering quickly and correctly.
Yes. Who doesn't like a prize pack? It's the best part of trivia.
We can auction off your hurricane houses to people.
If anyone wants a hurricane house, it's yours.
Especially house.
I saw a lot of people repping team or house number 3.
Team C was, or House C was definitely a favorite.
Yeah. I think it kind of looks like a spaceship a little.
I think it looks like a mushroom.
It does. Oh, I should have designed it to look like one. But that's something you guys can do at home. And we would love, if you guys do your own house at home, please send us pictures. You can email them or share on our Facebook page. We would love to see some of the houses you guys come up with. I'm sure you guys can do much better than me, so I challenge you. So I think we'll give it another minute. And also, guys, if so the questions will come up on our screen here, and then you will answer on your phone. So you'll have the 4 options pop up on your phone, and that's how you answer. But the questions will be up on our screen. So you might have to kind of switch back and forth. And I think we're ready. Trinity, you ready to start?
Yes, I'm ready. So for the first question, where are hurricanes the most prominent in the world? And for each question, you have 20 seconds to answer.
We have some quick ones already.
I know. Someone answered within a second. That was really fast. 3 more seconds. The Pacific Ocean. So 6 of you got it right. That's pretty good.
So even though we talk a lot about hurricanes in the Atlantic, we also have them occur in other places around the world. They might go by other names. Check out our leaderboard. Nice.
On to question 2. Which of the following are other names for hurricanes? And hint, there's more than one answer. So if you answer one of the answers, you'll get it correct either way. Everybody got it right. Awesome.
Some people climb up. Nice. Question 3.
How many categories of hurricanes are there? This one was answered very quickly too.
Yeah.
Look at all these smart people. Good job.
Good job, guys.
Where in the hurricane are the winds the strongest? So we included an image that will display certain parts of the hurricane. Well, good job. That one was a little harder.
So we know in the eye, it's nice and calm, but those eye walls will have some very strong winds.
What type of weather is associated with hurricanes?
Sorry about that. Awesome job, guys. It's getting a little close there.
When is hurricane season? And our guest speaker did talk about this at the beginning of the lecture.
So pretty good time of the year.
Mm-hmm.
The wells are killing it.
What are 2 things that a hurricane must have to form?
Yes. Those nice warm Atlantic waters and strong winds. So pretty close. Got a few more questions.
Which part of the hurricane is shown by the arrow? Good job.
That is the eye, the center of the storm. Okay, guys, let's see. Question 9.
So the arrow is pointing to a different part of the hurricane now.
Guys. Ooh, we had a big jump. Okay, 2 more questions.
How often are hurricane names reused? This one's my favorite question.
Yep, so they are rotated and they have a set list. So I've always wanted to have a hurricane named after me. And I found out the only way there could be one is if it was in the Pacific. So an Atlantic hurricane would never have my name, but you can definitely look up the names in the list that on the NOAA website. And we have one more question.
What does NASA stand for?
Can't forget the aeronautics, like she said. And we'll check out our podium for this evening. We have Cece in 3rd place, not bad. In 2nd is Paul, and then in 1st place, Noah. So if you guys want to put in the chat your email, and Sarah will grab that from you guys, so we have that information, and we can send you your prize pack. But well done. I think you guys all did great. And I'll stop sharing for just a moment. And I'll quit my Kahoot music, even though it's riveting. But I do want to thank you guys so much. Thank you, Trinity, for making that Kahoot. If you guys have any other questions, feel free to leave those in the chat. And I believe they left that email address for you guys as well. But we do want to thank you guys so much for attending this evening in our January Discovery Lab. For more information about our upcoming events and our upcoming Discovery Labs, don't forget to check out our social media platforms, and we'll post some information about those coming up, whether it's registering for them, if they're going to go virtual again, all that information can be found there. So again, thank you guys so much for joining us. A lot of new first timers. So we definitely hope to see you guys in February.
We did record it, and we'll post it on our YouTube page. So just give us a couple days and then it'll be up there.
Yep. Thank you guys. I'm glad you guys enjoyed it.